let's look at. Do you have any question? So I posted your grades in Bangalore, so you can check them. So, do you have any question? Right. So today we're going to do section 7.5, the uniform motion, work, and problem solving. Uniform motion. So this is the application part of the rational equations. Right. So if you have the handout there, then we're going to solve some of the questions there in relation to the motion, in the relation to work, and I hope you will get to know the application part of it. All right, so let's start from question number 1. And this question number 1 is dealing with work. So one of us can read for us question number 1. Maybe I can start from here. Okay. Yeah.
Paul can clean a classroom for 3 hours when his assistant helps him, and that takes 2 hours. How long would it take the assistant to do it alone?
All right, so it says Paul can clean. Is it that one? So it says Paul can clean a classroom floor in 3 hours. And then when his assistant helps him, the job takes 2 hours. How long would it take an assistant to do it alone? Okay, so we have here Paul can take 3 hours. So Paul, let's say Paul can take 3 hours. Then when his assistant helps him, the job takes 2 hours. So when he has the assistant, so let's say assistant plus Paul, it will take how many hours? 2 hours. So the assistant plus Paul will take 2 hours. Now, the question is, how long will it take the assistant to do it alone? So how long will it take the assistant to do it alone? So let's say the assistant, let's put the assistant will take, let's say, S hours there, okay? Now, in 1 hour, Paul will have done 1/3 of the what? Of the job, okay? In 1 hour again, the assistant will have done 1/S of the job. And then in 1 hour, Paul and the assistant will take 1 all over 2. So what will be the time that will take the assistant to do the job alone. So that means it will be 1/3 for Paul plus 1/s for the assistant is equals to what? 1/2 for the what? For the two of them. Okay? So now you look for the value of what? The assistant, which is s. So now, what will be our greatest common factor there? 6 what? 6s. So we multiply by 6s here, and then what you do on one side, you do it on the other side, 6s there. So when you multiply this, then this will divide by that, you get what? 2s plus this s and that s will cancel, you get 6 equals to this and that will be 3s. Okay? So you can take these 2s to the other side. So what do you get? 3s minus what? Minus 2s equals to what? Equals to 6. So s is equals to 6. So the time that the assistant will do the job is what? And then you make sure you put the units there. 6 hours. So the assistant will take 6 hours to do the job alone. All right? Okay, so the next question there. Samuel can read for us.
Washing his dad's car alone, 8-year-old Levi takes 2.5 hours. His dad helps him and it takes 1 hour. How long does it take Levi's dad to wash the car by himself?
All right, so washing his dad's car alone, 8-year-old kid Levi takes 2 hours. So Levi will take how many hours? 2.5 hours alone to wash the car. If his dad helps him, then it takes 1 hour. So if the dad helps him, so Levi plus the what? Dad will take how many hours? 1 hour. How long does it take Levi's dad to wash the car by himself? So now, how long will the dad take to wash the what? The car. How many hours will it take to wash the car? So it's similar to the first one. So that means for 1 hour, Levi will have done 1/2.1, 2.5. So 1 hour, Levi will have done 1/2.5. For 1 hour, Dad plus Levi will have done 1/1, which is equals to what? Which is equals to 1. Then for Dad alone, so 1 hour, the dad will have done 1/what? Let's say 1/d. So let's say d is the 1 for what? For dad. So how long does it take Levi's dad to wash the car by himself? So here it will be 1/2.5 plus 1/d equals to what? Equals to 1. Equals to 1. Equals to 1. So you get now the value of d. So what will be d? So you can multiply by the least common, the greatest common factor there, which is what? 2.5. 2.5 D. So you also multiply here by 2.5 D. So what do you get? So this 2.5 will cancel with that. So what remains there is D, plus this D will cancel with that D there. So what you get is 2.5 equals to what? 2.5 D equals 2.5 D. So you can take the D to the other side because this D here is small. So 2.5 equals to 2.5 D minus what? Minus D. So what do you get there? So you get 2.5 all over what? 2.5 minus D is what? Minus 1 is what? 1.5, right? Equals to what? Equals to D. So what will be our answer? So what is D? So by 5 is 5, by 5 is 3 there. So you get 5 over what? 5 over 3 hours. So the dad will take 5 all over 3 hours to complete the job alone. Okay, Destiny, read for us number 3.
It takes 3 hours to mow the lawn, while a cousin barge takes 2 hours. How long will it take them working together?
All right. So it's similar to the first one and the second one, right? So how will you do that? So it says, so Lisa will take 3 hours to mow the lawn, while the cousin, which is B, will take 2 hours. How long will it take them to work together? So how long will it take them to work together? So we can take L plus B to be equals to what? Time, which is what? T there. So it will take the T hours for them to work together. So what is T? So it will be 1 over 3 for Lisa to take for 1 hour, and then plus 1 over 2 for the cousin to take for 1 hour, equals to 1 over what? Equals to 1 over T. And then you get the value of T there. So the greatest common factor there is what? 60, and then 60 there. So when you cancel here, you get 2T plus. When you cancel this and this, you get 3T equals to what? When you cancel that and that, equals to 6. So this and this will be 5T equals to what? Equals to 6. 2T equals to 6 over 5 hours. So it will take 6 all over 5 hours for them to complete. So when you do your homeworks, Newton will expect you to put this one in minutes. So you can change this one to minutes. So by doing what? Multiplying by 60. So 6 all over 5 times what? 60 minutes. So you get how many hours? How many minutes? By 5, 1, by 5, 1. 72 minutes. So it will take 72 minutes for them to complete together.
Are they gonna want the same for example number 2 as well?
Yeah. So I think it wants you to put them in minutes. So if there is a fraction there, you put them in minutes. Okay. Yeah. All right. So number 4 is similar to number 2. Then let's go to number 5. Let's go to number 5. Number 5. Anyone can read for us? Yeah. Okay.
Nathan walked on an asphalt pathway for 12 miles. He walked 12 miles back to his car on the gravel road through the forest. On the asphalt, he walked 2 miles per hour faster than on the gravel. The walk on the gravel took 1 hour longer than the walk on the asphalt. How fast did he walk on the gravel?
Okay, so this one is dealing with motion. Huh? So this one is the application to motion. So when we were, I think when we were starting the course, almost at the middle, so we said speed equals to distance of what? All over time, right? So speed equals to distance all over time. Or this is similar to distance equals to speed times what? Times time. So this is the speed, and this one is the time. That's the speed, and that is the time. So our question is, how fast? How fast? So what does that mean? We are looking for what? What are we looking for? We are looking for the speed, right? So we're looking for the speed. How fast did he walk on the gravel? So we can take the speed for walking in the gravel. This is the speed for walking on gravel. So you can take G to be the speed for walking on the gravel. So it says Nathan walks on the Alpha pathway for 12 miles. So the miles are 12. On the what? On the asphalt. He walked 12 miles back to his car on the gravel road through the forest. So he walks 12 miles back to his car on the gravel road through the forest. So he walks back 12 miles on the gravel road through the forest. On the Alpha, he walks 2 miles per hour faster than on the gravel. So the miles are what? 12. Okay. So here, to get a distance, or the distance we are given there. So what are we looking for? We are looking for the what? Let's say we are looking for the time. So the time is the same as what? Distance all over the what? The speed. So we have the distance here as 12 miles. 12 miles. And then the speed on the alpha, it works, alpha, it works 2 miles per hour faster than on the what? On the gravel. So on the alpha, this one is alpha, it works. So for the gravel, the speed on the gravel is G plus 2 miles faster than the what? Than the one working on the what? On the gravel. So this, now to get the time that it took to work on the alpha will be what? So it will be 12 all over what? G plus 2. 12 all over G plus 2. Now, the next statement is the work on the gravel took 1 hour longer. The work on the gravel took 1 hour. So this is the time. Okay. So this is the time that he used to work on the what? On the alpha. Now it took 1 hour longer. So 1 hour longer than the work on the what? Alpha. So this time is the same as the time for working on the what? On the gravel. Okay? So it took him 1 hour extra for working on the alpha and gravel. So what will be the time for working on the gravel? So it will be 12 all over what? All over G, right? So this is the time for working on the gravel. And this is also the time for working on the gravel. So this is equals to this one. So it will be 12 all over G plus 2 plus the extra 1 hour equals to 12 over what? Equals to 12 all over G. Did I confuse you? So this is the time. So the statement says on the alpha, it worked 2 hours, 2 miles per hour. So that one is the speed, 2 miles per hour faster than on the gravel. So the speed of the gravel is, we say it is G, okay? And then now it works 2 hours faster than on the gravel. So it will be, to get the speed for working on the alpha plus the speed and extra speed, it will be plus an extra time, it will be equals to 12 all over G there. Now we need to look for the value of what? G. So we multiply by the greatest common factor there, which is what? So what is our greatest common factor? So our greatest common factor will be what? G plus 2, and then times the what? Times G. So G plus 2, which is this, times this G over here. So what you've done here, then you do it in the other side, plus 2 times. So when you open the brackets, so this G plus 2 will cancel with that, you remain with 12G there, and then plus, there is nothing which is canceling here. So it will be G plus 2 times what? Times G equals to what? This G will cancel with that, equals to 12 G plus 2. Then you open these brackets here, so 12G plus G square plus 2G equals to 12G plus what? 24, plus 24. Then you collect the like terms there. So of course this one will cancel with that, okay? So you remain with G square plus 2G equals to what? Equals to 24. So G square plus 2G minus 24 equals to 0. Equals to 0. So that is a quadratic equation. So we can use any method. So we can use the AC method. So AC equals to minus 24, and then B equals to 2. So what are the two numbers in which the product is 24 minus 24 and the sum is 2? What are the two numbers? 6 and what? -4, right? So 6 and -4. So we have G square plus 6G minus 4G minus 24 equals to 0. So we factor out the common factor in the first one, which is G. So G plus 6 minus 4. We factor out 4 there. G plus 6 equals to 0. Then we factor out again the common factor. So G minus 4, and then G plus 6 equals to 0. Now, using the zero product property, so using the zero product property, what do we get? So we get G minus 4 equals to 0, or G plus 6 equals to what? Equals to 0. So G equals to 4, or G equals to minus 6. G equals to minus 6. So we get a speed as G equals to 4 and G equals to minus 6. So which one should we take? 4, right? Because we don't have the negative speed. So we ignore the 6 there. So the speed that this guy will take to work on the gravel will be 4. So what are the units?
Miles per hour.
Miles per hour. 4 miles per hour. Don't forget the units, okay? So if you forget the units, you get half of the mark will go. Okay, someone to read for us number 6.
Hudson travels 1,080 miles in a jet and then 240 miles by car to get to a business meeting. The jet goes 300 miles per hour faster than the rate of the car, and the car ride takes 1 hour longer than the jet. What is the speed of the car?
So what are we looking for? We are looking for the speed of the what? So we can say this, what is the speed of the car? So here we are looking for the speed of the car. So we can name S as the speed of the what? Of the car. S as the speed of the car. The question is, Hudson travels 1080 miles in a jet, then 240 miles by car to get to a business meeting. The jet goes 300 miles per hour faster than the rate of the car. So here, the distance for the jet distance is what? Is equals to 1080. Then 240 miles by the car. So car distance is 240 miles. The jet goes 300 miles faster. So, okay, so the speed of the jet, is what? 300 miles faster than the rate of the what? The car. So what is the speed of the jet? So it's 300 plus what? Plus S. So the speed of the jet is 300 plus S. Faster than the rate of the car. And the car ride takes 1 hour longer than the what? Than the jet. So the car will take how many hours? So we have the distance for the car as this, okay? And we have the speed of the car as that one. The speed of the car is S. So what will be the time for the car? So the time for the car equals to what? Distance all over what? All over speed, right? Distance over speed. We have the distance for the car is 240. All over the speed is what? The speed is S. Now it says the jet goes 300 miles per hour faster than the rate of the car, okay? And the car ride takes 1 hour longer than the jet. So what is the time for the car? So the time for the car is this. So this time for the car is 240 all over S is the same as the time for the jet plus how many hours? Plus 1 hour. For the time for the jet will be what? We already have the speed of the jet is 300 here. So 300 plus what? Plus S. And the distance is 1080. So it will be 1080 all over 300 plus S plus the 1 hour plus the extra 1 hour. So this is the time for the car, which is similar to the time which you get from this. Now we are looking for the what? S. We are looking for the speed of the car. So what will be our speed for the car? So what is our greatest common factor there? S times what? 300 plus S. So we multiply everywhere by S times 300 plus S times 240 all over S equals to 1080 all over 300 plus S plus 1 times what? S 300 plus S. Then we open the brackets. So when you open these brackets, this S and that one will cancel. So you get 240, 300 plus S equals to this 300 plus S will cancel with that. You get 1080 S. This, there is nothing to cancel here, right? So plus S 300 plus what? Plus S. So you open the brackets. So when you open the brackets, 240 times 300 is what? So 72,000 plus what? 240S equals to 1080S plus 300S plus what? S squared plus S squared. So we collect the like terms. So we have 1080S plus 300S. What do you get? And then minus 240. What do you get? $11.40, right? So you get 72,000 equals to 1140 S plus S squared. So we can take the 72,000 to the other side, then you get S squared plus 1140 S minus 72,000 equals to 0. So you use the AC method, you look for two numbers, which the product is minus 72,000 and the sum is 1140. So what are the two numbers?
60 and 1,200.
So you have 60 and 1,200. So S square, so which one will be minus? The 61, right? So plus 1,200 S minus 60 S minus 72,000 equals to 0. So when you factor out S, so you get S plus 1,200 minus 60 S plus 1,200 equals to 0. So when you factor out again, S minus 60, S plus 1,200 equals to 0. So using the zero product property, so you get S equals to 60 or S equals to minus 1,200. So definitely we don't have the negative speed. So we go for what? 60. So the speed for the car would be 60 miles per hour. 60 miles per hour. Right, so number 7 is similar to number 6. So it's similar to number 6. So we still have like 4 or 5 minutes. So I can give you a hint. So someone to read for us. Number 7. You can read for it, yeah.
Devontae rode his bike uphill 5 miles and then back downhill. The rate which Devontae traveled downhill was 20 miles per hour faster than his rate going uphill. It took him 20 minutes longer to ride uphill than downhill. With what was his uphill rate?
So first of all, you change the minutes there to what? 2 hours, right? So 20 minutes is how many hours? Is how many hours? 20 of what? 60, right? So it's 1/3 hours. So you change the minutes to hours. So you change the units. You make sure you have the same units. So this guy rode his bike uphill. So going uphill, 5 miles. So 5 miles. And then back downhill. So that's the same. They're covering the same miles, right? Going up and coming down. The rates at which this guy traveled downhill was 20 miles per hour, faster than his rate going uphill. So downhill will cover, so let's say this is, let's say uphill is, let's put the speed as R, miles per hour, okay? And then the rate at which this guy traveled downhill was 20 miles per hour faster. So faster than the other one. So it will be what? R plus what? Plus 20. So this is the speed for coming downhill, miles per hour. What was his, what's the question? If it took him 20 minutes longer to ride uphill, so if it took him 20 minutes longer to ride uphill than downhill, what was his uphill rate? So how will you solve that? So so it took him time to go uphill is the same as what? Distance all over what? All over time. So 5 over R. Time to come downhill is what? Is equals to 5 all over R plus 20 plus how many minutes? So it took him 20 minutes again. So that means plus 1/3. So this time here is equals to this. So you equate that one. So 5 all over R equals to 5 all over R plus 20 plus 1/3. And then you solve the value of R. And R is the what? Is a speed to go what? To go uphill. All right? So you go and try that one. The solution is in your notes. So before we go away, let me check the roll call here. Avalos. Gregory. Ashley. Victoria. Rachel. Bailey. Laura. Adam. Kavehi. Andrew. Destiny. Call. Abby. Aliyah. Aldo. Jillian Martinez. Remington. Rayleigh. Eric. Relay. Rock. Thompson. Samuel. William. Rockman. All right, see you guys. So next Friday is your second exam. So make sure you try read over the weekend. What?
Are you gonna post a postcard?
Yeah, I will post that to you. All right, see you.